Hey guys, welcome back to the CYPHER series. This is episode 3, Into Titan's War. Hey, I am Shashwat Kumar Das, your narrator throughout this series. There's a quote: to open a door built by genius, they must teach a machine to think. So, in this episode, we're going to see the AI concept called neural networks. Let's have a recap of the previous episode. Aarav and Nisha stuck in the year 1577, a fractured alternate Delhi ruled by Titan, the king of darkness. Their mission was to escape back to the future in 45 days using a broken time machine. But the key isn't a code, it's a mind, a thinking system lost with Guru Samak himself. To unlock it, they must build a digital brain, that is, the neural network. So let's get back to the story and continue in our whiteboard. So, hey guys, welcome to the playground. So, where we're going to see the story. So, in this episode 3, I have added some images for better understanding, and also I have pre-written the notes which I was writing in the email part so it can be fast to understand, right? So, episode 3, Into the Titan's Vault. So, just imagine dark, dusty room beneath Titan's old palace. Blue light pulses from an ancient vault. Hour of coffee. What is the place? Looks like some kind of lab. Nisha wiping up the off a wall panel. Wait, look, Guru Samak's neural vault. It says only a mind that learns may pass through time. Arav. A lock that opens with intelligence. This isn't a code breaker, it's a test. Nisha. Exactly. We are not entering a password, we are building a brain. And then comes the console where Guru Samak's voice gets heard. Let's teach you what a neural network really is. So now we're going to learn what is neural network. A neural network is a computer program modeled after the human brain. Just like neurons in your head, it connects tiny units together to solve the problems. First step in the neural network is the input. Every problem starts with input. Imagine you're trying to identify a cat in a picture. The image is made of thousand numbers of pixel values. Data like images, sounds, or numbers are given as input. Next comes the neurons. Each input is passed to tiny functions called neurons. Like the cells in your brain, each neuron multiplies the input by a weight which adds a bias. And then it decides if it should fire or not. So we have a formula for this, right? That's the output formula that we use for the neurons, as you can see here. So it says that output is equal to the activation function that we use, right? The activation function that we use, and the weight cross the input plus the bias. So what I'm thinking in the upcoming episodes, we can have a collab notebook with doing the coding stuffs of machine learning, neural networks, deep learning, AI, everything. We will be doing that also. Next comes the layers. So as you can see here, neurons are arranged in levels. So first comes the input layer, right? Then comes the hidden layer, and then comes the output layer. So these are the three layers, the three basic layers that we have in the neural network. Okay. So you can see here, first comes the input layer. So you can see this diagram, right? So you can see this diagram, right? So first comes the input layer. So this one is the input layer. It's connected to the hidden layer. Now from this hidden layer, it gets the work done, and it gives the final output layer. So you can see the input. If the input layer we have over here is 4, the hidden layer is bit more, right? 1, 2, 3, 4, 5, and we have less output layer. That is 3, right? So this is how the layers are arranged. So neurons are stacked into layers. First is the input layer, which has the pixels. we can say, or the features, right? Pixels are the features that we have. Then comes in the hidden layer, which has where the learning happens, where it learns about the input data and what should be the output from the data set. Finally, an output layer which gives the answer. Like if you are doing something which you are identifying, you have given an input of cat and it should identify if that's a cat or not. You have given basically the feature of the cat, right? You're given the features of that cat. So it will identify with whether it is a cat or not. By the hidden layer, it does that. And then it gives the output, yeah, like it's a cat. Okay, like is that a cat? Right. Next comes the activation function. So next comes the activation function. So what does this do? This is what adds the intelligence. It's like saying if I want like if what I see is strong enough, I react. Okay, something like that. We often use something called RLU, which it simply says that if it is positive, keep it. If it's negative, drop it. Okay. So how does the activation layer? So first, we have two types of activation layer, by the way. One is known as sigmoid layer, right? Sigmoid activation layer, activation function, basically. So here you can see the how it looks, right? I'll just zoom in. So here you can see how it looks, right? How the graph looks. So this is the sigmoid layer you can see, and this is the say the active gradient function you can see over here, right? And it uses the chain rule to find derivative. So the it's like sigmoid activation function formula that we have is f of x equal to we can say f of x equal to 1 by x, right? Like sorry, 1 by 1 plus e to the power of minus x. So this is the formula for the activation function. Okay. Now we how we find it? We have find it following the chain rule to find derivative. So you can see here how it is found, right? And the final formula over here we can also write f of the dash of x is equals to f of x into 1 minus f of x, right? We can write something like that also. Okay. So this is about the activation, sigmoid activation function. Now, when we look at the RLU activation function, as you can see over here, you can see the graph is basically a straight line from the origin, right? It's just going in a straight line format. So this is how the RLU. So if it's positive, it keeps it. So only if it's positive, you can see over here. So only if it's positive, it's having the value, right? It's having the value. Now in negative, it just drops it. So if it drops it, it's the value is zero over here, right? So this is how it does. Now, how does the machine learning learns? Like how does the neural network learn? Okay. So as you can see here, the example of dog and cat. So we're using a binary image classifier, which is trained on neural network only, and it predicts whether this is a dog or cat. Mostly we use this neural network things in images, right? So where do we use this? We have CNN models, we have RNN models, which are basically the image based model. So we use these things in images probably. Okay. Now, how does it learn? So learning uses it uses loss functions. Okay, it uses loss functions. It adjusts the weights. It adjusts the weights with back propagation. With back propagation. Okay, with back propagation, it adjusts the weight. So a neural network doesn't start smart, it guesses randomly. Okay. Then it checks how wrong it was using something called as loss function. Okay, using the loss function, it checks like how much wrong it was. Okay, I'll just remove the annotated part. Yeah. Then it checks how wrong it was using something called loss. It adjusts all the weight using an algorithm called back propagation, and gradient descent. Okay, by using this algorithm, it adjusts all the weights using this algorithm. And the goal is to keep making better guesses until gets it right. That's how it learns. So if you can see the mountain, so if something is high, it again comes low. If high, it's come low. If high, it comes low. So this is how it learns basically, right? It learns about the machine. It learns about the input that we're giving. It learns about the features that we're giving. So according to that, it learns. So let's go back to the story. So here you can see I have used some images for better understanding, like to make it look good. Okay. So here in the image, you can see first, let's consider the scene, like have an imagination of the scene that Aarav and Nisha are connecting glowing rods and crystal nodes, visual metaphor for neurons. Okay. So each of these, now Aarav says that, so each of these nodes, it's like a digital brain cell. Then Nisha says, exactly, the input neurons take in the patterns that Titan's past behaviors and the wall data and the voice patterns. Then Arav says that. And the hidden layer, that's where the system thinks. Then Nisha, yes, this isn't just programming, this is learning, like a kid figuring out how to walk by falling over. Yeah, like a kid, like a learning, like a kid figuring out how to fall or walk by falling over. Nisha repeats the last bit. Now, let's visualize the neural net visualization view. Now, Arav watching it. So, Arav watching it, it says it's actually adjusting itself. And Nisha springs and says, welcome to Delhi 1577. Now, let's see some example how the neural network powers so much today, right? Tesla uses them to steer car. Face ID in your iPhone or Face ID in your iPhone or even in Samsung phones, you have the face unlock. They also use neural networks. Then your voice assistants like Siri and Google Assistant, they also use neural networks. And the famous ChatGPT are built on deep neural networks, right? The ChatGPT that we use in our daily over, right? So neural networks power so much today that even Netflix uses them to recommend shows sometimes. Okay. So neural networks are everywhere today, right? Like Face Unlock uses CNN, a type of neural network for images, right? So that also where there also we use neural networks. So neural network is everywhere. Okay. We'll have a quick recap after completing the story. Okay. So now Nisha types something in the keyboard and there comes inputs connected, layers built. We trained it on the train Titan Sports sample. Our this is our artificial brain. Let's see if it thinks like Guru Samax did. Nisha. Back propagation. It's comparing its output with what it should be and correcting itself. Arav. Wow. Wow. It's adjusting itself. So we are building what powers the modern world with this Stone Age tools. Nisha. Welcome to Delhi 1577. Then Glyph glows and the Titans, the like Titan appears and he says, you built a machine mind, but beware. Every door it opens reveals a deeper shadow. Arav, what did he say? What does that mean? Nisha, we didn't just unlock the world, we woke it up. So that's the end of this episode 3. And in the upcoming episode, as I told you, I'll be using collab notebooks and that collab notebook we will be doing some coding stuff. We'll be building machines, we'll be building neural networks. Okay, so that's why the next chapter is going to be deep learning, and we'll be learning about that in the upcoming episode. That is the episode 4, Cypher, the Deep Dream, where we enter the world of convolutional neural networks and AI vision. Okay, so I will meet in the next episode. Before that, let's have a quick recap of what we learned in this episode. So, what we learned in this episode, neural networks are made up of simple math functions called neurons. They're organized in layers, right? They learn from examples using backpropagation. The more layers, the deeper the network and the more it can understand. Okay. So let me just write down this over here so that you can also note it down that what we learned in this class. Okay. So first we learned that when we made what are neurons? So they are made of simple neural networks are made of simple math functions, right? They're made up of simple math functions called neurons, right? Called neurons. Like you also know, like neurons are used in a brain, right? So when we message something, it goes to the neurons only, right? So that's how it works. And then we have everything is neural networks are organized in layers, right? Organized in layers. We saw the three types of layers also, right? They're organized in layers. And then we have they learn from examples using backpropagation, right? They learn from examples using backpropagation. And then we learned that the more layers we have, the deeper the network and the more it can understand, right? So these are some quick recaps that we have done in this episode. I hope so you will like next episode because next episode is a bit high up. I'm going to keep like I'm going to have collab notebooks and next episode will be full on hands-on. So I hope so you will like next episode. So let's meet in the next episode. Thank you. Have a great day.